Hello everyone, my name is Ricardo Barbosa from ISIS. We are a research center of the Department of Civil Engineering of the University of Minho in Portugal. Today, I will be talking a little about one of the venues that we are exploring regarding energy poverty and the project we are currently involved in focusing on social housing. It is now very clear that energy efficiency is a priority if we want to achieve our goals of a decarbonized Europe by 2050. One of the key areas in which the European Union has been focusing its policies is the built environment. In particular, existing buildings, which are in large number and widely deficient in most countries, are of concern and have received special attention because of their potential for achieving significant energy savings and carbon emissions. The inefficiency of the existing building stock is one of the key factors that are behind also of the recognized problem of energy poverty. Portugal has been identified as having a particularly high risk of energy poverty. Although the meaning of what is social housing is not the same throughout Europe, social housing buildings account for a significant share of the residential housing stock. In the case of Portugal, it accounts for about 2%. Although it is important to point out that social housing buildings share construction characteristics and methods with many of the Portuguese residential buildings, in particular with the ones built from the 1980s. In Portugal, social housing consists of buildings that are publicly owned, managed by the municipalities or the Institute of Housing and Urban Rehabilitation. Energy poverty is, of course, a pressing issue in social housing contexts, not only because of the reduced incomes, but also due to the fact that buildings are mostly constructed at controlled costs with poor quality. These buildings generally present constructive solutions that do not meet current energy performance requirements, and as a consequence, it is common for these buildings to present several pathologies and suffer from lack of maintenance as well. In general, several benefits can be found associated with increasing energy efficiency of the social housing stock. From a social point of view, there is evidence on how the investments in energy efficiency can provide an increase in disposable income and reduce energy bills, as well as improving indoor housing conditions. There is also the possibility of achieving economic benefits at a broader level, as promoting such interventions can boost an increase in labor demand and help to reduce air pollution in urban areas. However, while the broad range of benefits are increasingly recognized, there are several difficulties preventing widespread renovation of these buildings and neighborhoods. On the one hand, in the context of social housing, there is a situation usually known as split incentives, in which there is a discrepancy between who is responsible for financing the intervention, the municipality for instance, and who pays the energy bill and enjoys energy savings and thermal comfort, which will be the users of the building. On the other hand, the vulnerable economic situation of residents can result in rent delays, which will also decrease the motivation of the building owner to carry out this type of interventions. There is funding available, such as the one foreseen in the Planned Recovery and Resilience Plan, but in order for this and other programs to improve the housing park to be effective in promoting energy efficiency, it is necessary to direct investors to cost-effective measures to reduce the risk of energy poverty and ensure that these investments result in consumption appropriate to the income of the population residing in these type of buildings. So ARCAS focus on the intersection and resolution of these problems. It is funded by the Interreg Sudoe program, and the consortium is consisted of 5 institutions of Portugal, Spain and France. ARCAS aims to develop a multi-criteria assessment methodology for the renovation of buildings and group of buildings of social housing with the objective of mitigating energy poverty and promoting sustainability, energy efficiency and health in the Sudoe territory. Although the project scope aims at aggregating different dimensions for the assessment of the renovation of social housing buildings, in this presentation we are focusing on the energy poverty issue. In this context, we studied the integration of several indicators of energy poverty in the methodology. One of the experiments we conducted is related with the relation between the effect of renovation interventions and the actual alleviation of energy poverty as a consequence. For this presentation, we chose two simple and objective indicators to demonstrate it, the so-called 10% indicator and the 2M indicator. For this approach, we used as a case study a neighborhood of social housing in the city of Braga, managed by Braga Beats, which is currently carrying out intervention in some of its buildings. The district consists of 11 multifamily housing buildings with 4 floors. They are typical buildings of this type of construction with an envelope with a very high thermal transmittance. For this analysis, we simulated several types of measures for an apartment in the upper floor as indicated in the image. In the first phase, we took an approach focused on isolated measures for roof, walls, and glazing, and then organized the measures into 6 intervention packages, which combine all of them. So in order to understand the effect of these measures on energy poverty, we conducted a cost-effectiveness analysis where the renovation measures are compared with a reference situation in which no improvement of energy efficiency is made. The interventions take into account the life cycle of the building, which in this case was considered to be 30 years. In the graphs, you can see global cost in the y-axis and total primary energy in the x-axis. Finally, the size of the marks are indicative of the effect on energy poverty according to two indicators. The bigger marks indicate that the result surpasses twice the indicator thresholds. The medium-sized marker that are above the thresholds, and the smaller marker means that is below the threshold for the study indicator. So you can see that most measures have a positive cost effectiveness. We can also see that in terms of isolated measures, the one that allows for a greater energy saving is the insulation of the roof, about 40%. When analyzing the intervention packages, it is verified that they allow to achieve a decrease of 70% primary energy and 56% of the annual cost. With regard to the assessment of energy poverty, the calculations suggest that in the case of the indicator 10%, both the reference situation and the isolated measures related to glazing and walls are indicated as presenting values above twice the limits, which means that these families could not bear these costs and will be in the situation of energy poverty. In the case of the 2M indicator, all isolated measures are above the limits. In this indicator, it is worth highlighting the result of the cost-optimal solution for the renovation of the roof, which is mineral wool, which allows reaching values below what is considered an energy poverty situation, and establish a relationship between the cost-optimal solution and the alleviation of energy poverty. In addition, the results calculated in any of the indicators reveal that the aggregation of measures allows to obtain values below the limits considered for the assessment of situations of energy poverty. In conclusion, the results for different EP indicators show significant differences, and we are going to deepen the analysis using other case studies with more indicators and more measures. The results seem to indicate that energy efficiency have to be significantly improved in order to be possible to relieve EP situations. And the approach also highlights the choice of cost-effective measures to establish adequate energy consumption for low-income users. Finally, we realized that, as it was one of the objectives, the approach can be useful in informing decision makers about the ability of energy efficiency measures to reduce the risk of energy poverty in social housing contexts. For more information about the project, you can go to the website or get in touch with us. Thank you.